Hi students, today we are going to discuss a new concept, gravitation. What is gravitation? Actually, the gravitation is a type of force which is weakest among all the forces. Means if you take nuclear forces is the strongest force, electrostatic force is the next order, the least the gravitational force. The gravity is depend upon mass of the objects. Means the gravity is basically mass dependent phenomenon. If an object have more mass, it has more gravity. If an object has less mass, it has less gravity. Here also, we define what is the gravitational force. The gravitational force is nothing but here in our universe. Every two objects attract each other in accordance with Newton's gravitational law. Here also is the force of attraction between two bodies due to their masses. Every body on Earth's surface try to fall towards the center of it due to gravity. Is whenever an object is in the influence or in the field of gravity, is try to fall down towards the center of it. Means the gravitational force nature is purely attraction. What are the basic properties of gravitational force? The properties are also important. Here the gravitational force between two bodies is action and reaction pair. Here action and reaction pair. The forces are equal in magnitude but in opposite direction. And the second important property is the gravitational force independent of medium does not depend upon intervening medium between the two objects. It is independent of medium as well as its exists in phase only. Means the forces acting on each other in opposite direction. Suppose this is an earth, this is a moon. The earth attracts moon towards the center of earth as well as moon attracts earth towards the center of moon. The forces are acting in opposite direction. That's why here I mentioned opposite direction. Opposite direction. What is the next property? The gravitational forces are negligible in case of lighter objects. Lighter objects in the sense, if you take gas particles, where we have studied kinetic theory of gases, we neglect the gravity on gas particles or molecules. Why? Because they are very, very small. As very, very small, nothing but the mass is negligible. Whenever mass is negligible, obviously gravity is negligible. This is the third important property. The next one is the gravitational forces are predominant or very high in case of heavier objects like stars and planets. Stars, planets. Why? Because mass is more. Mass is more. When mass is high, gravity is high. That's why I said the gravity is mass dependent phenomenon. The next one, it is the weakest force among the all. We already discussed that the gravitational force ratio to electrostatic force as well as nuclear force. This is the force of gravity. If it is 1 unit, the electrostatic force is 10⁻36 times the gravity, and the nuclear forces are 10⁻38 times to the gravity. This is the order. Means among the all forces, the gravity is weakest force, and the forces are conservative in nature. What is the meaning of conservation? The net work done in the whole process is zero. Even though, suppose if you observe, the earth is revolving around sun, sun is one of foci of ellipse. In this case, there is no motion earth towards the center of sun. Why? Because as there is no displacement towards center, the work done is the force into displacement. There is no displacement, nothing but the work done is zero. That type of forces are called conservative forces. The forces are exist between the two bodies, but the net work done in the system is zero. Such type of forces are called conservative forces. Here, the gravitational forces are also called conservative forces. The next property is it is a mass dependent and charge independent. Mass dependent and charge independent. It does not depend on charge. We should not consider charges of objects while we are discussing gravitational forces. But we discuss about masses. This is a mass dependent and charge independent. Whereas if you consider nuclear forces are also taken as charge independent forces. Why? Because we should not consider the charge between proton and proton and neutron inside the nucleus. That's why these are also charge independent as nuclear forces. The next topic is which of the following is a property of gravitational force? This is an objective question based upon the theory discussed. Is the weakest force of all the forces? Yes, it is the correct answer. The next option is it has a long range forces, means the forces are acting when objects are at very large distances, just as the sun and planets. There exists a gravitational force. These are said to be long range forces. Means this is also correct option. This is also correct option. The next one is it is mass dependent. This is also correct option. All of above. The correct option is D. The correct option is D. Means this is the basic question or depend upon the properties of gravitational force or the nature of gravitational force. This is the correct option is D. The next one is what is universal gravitation? This is a basic law proposed by Newton. What is Newton's gravitational force? According to Newton's gravitational law, there exists a gravitational attraction between any two bodies in our universe. That is the basic gravitational law. Here we take M1 is the mass of object A, the mass is M1, and there is another object M2. They are separated at a distance R. Then, such a case, there exists a force. The force acting on A due to B, in the same way, the force acting on B due to A. That's why there are two forces acting in opposite direction. Action, reaction pair. In such a case, according to Newton's gravitational law, the force is proportional to the product of masses. The product of masses M1 and M2, as well as the force is inversely proportional to R square. Separation between them means maximum forces are satisfying inverse square law. Means the inversely proportional to square of the distance. F is inversely proportional to R square, or F is proportional to 1 by R square. If you combine these two equations, you can write F proportional to M1 M2 by R square. If you want to remove this proportional constant, we can add a constant that is universal gravitational constant, that is capital G. The G is called universal gravitational constant. The G value is, what is the G value? The G value is 6.67 into 10 power minus 11 in magnitude. That's why here, if you observe question on this one, the gravitational force directly proportional to. This is also basic question. You can attempt easily. The product of masses, the sum of masses, and division of masses. Which one is correct answer? From this equation, the gravitational force proportional to the product of masses. M1 M2 nothing but M1 into M2. That's why the correct option is option 1. Let us coming to next concept. The gravitational force is mathematically given as this. They asked me about the gravitational force equation. What is the equation? F equals to G M1 M2 by R square. G M1 M2 by R square. Which one is correct answer? Option C is correct. Option C is correct. The next one is in Newton's law of gravitation. G is called. You know what is G? G is universal gravitation constant. That's why the correct option is option A. There is a basic equation what we derived in Newton's gravitational law. Now we have to discuss about the gravitational constant also. Why? Because they are often asked the dimensions formula as well as units of constants. Thus, we have to discuss about what is the dimensional formula for gravitational constant, as well as what are the units of gravitational constant. Here, if you observe this one, universal gravitational constant, F equals to G m1 m2 by r square. If you rearrange this equation for G, if you rearrange this equation, then you can write f r square by m1 m2. That's what I wrote. F r square by m1 m2. If you rearrange the equation, if you write the dimension formula for this one, and as well as what are the units, the force units are newtons, our distance units are meters. That's why meter square. The m1 m2 kg into kg, then nothing but kg square. That's why the newton meter square per kg square are the SI units of gravitational constant. Or in CGS units, the dyne per centimeter square per gram square. What is the dimensions of Z? Here, just to derive the equation for every term, we have to write the dimension formula. Here, the force dimension formula, as well as R, the distance dimension formula, the mass dimension formula. If you write those dimension formulas, then what is the force dimension formula? The force is equals to, from the equation of F is equals to ma. The dimension formula of mass is capital M. The dimension formula of A is m. The dimension formula of A is LT power minus 2. LT power minus 2. That's why this is the dimension formula for force. What we write here? MLT power minus 2. In the same way, R square. R nothing but length. That's why we have only the component of length only here. This is the remaining terms of 0. Whereas M1, M2 means M1 into M2, M square. Here, the dimensional formula of mass is M, another mass is M square. If you simplify this equation, what is the dimensional formula for G? That is important. You should keep in mind, that is M inverse L cube T minus 2. That is important. M inverse or M power minus 1 L 3 T minus 2. This is the basic dimensional formula for gravitational constant. This is important. What is the value of G? The value of G is 6.67 into 10 power minus 11. The basic units are Newton meter square per kg square. Or in terms of dynes, we can express 6.67 into 10 power minus a dyne per centimeter square per gram square. That is in terms of CGS units, whereas this is in SI units. SI units. Most often you are using SI units only. And depend upon the concept, we have to answer this question. Universal gravitational constant numerically equals to. Just to discuss, what is the universal gravitational constant? From the definition, F is equals to G m1 m2 by r square. If force equals to gravity, in which case the mass is unity, m1 equals to m2 equals to 1. If every component in this equation is 1, r equals to 1, then such a case means if two unit masses are separated at 1 unit distance, then such a case the gravity is equals to force. That's why here the correct option is the force of attraction between unit masses and unit distance. Unit is nothing but here 1. That's why here m1 equals to m2 equals to 1 as well as r equals to 1. In such a case, F equals to G. We define gravitational constant in this fashion. That's why the correct option is option 1. The next concept is, what is the dimension formula of gravitational constant? Just to derive what is the dimension formula, which one is correct option here? Option 3. Option 3 is correct option. The derivation is already in this fashion. Okay. The next one is, what is the value of gravitational constant? This is obviously know. The value in SI units I give 6.67 to 10 power minus 7. What is the vector form of universal gravitational constant? We can express in vector form also. In every equation, we can express a vector form. Why? Because here masses are separated at distance or The acting forces F12 means the force on 1 due to 2 as well as F21 nothing but the force on 2 due to 1. There exists the pair of forces. Here F21 equation is like this. This is one form of vector equation. F is equals to G M1 M2 by R square. Here if you observe the forces acting along the radius or the separation between two masses. Here R21 nothing but here R21 nothing, the force acting on 2 due to 1. Here in this direction R21, in the same way you can write R12 also. How much the forces are acting in magnitude? We remember here F21 is equals to F12, but they are acting in opposite direction only. Here in vector form, if you represent that one R12, that is the force between 1 and 2. The force R12 represented here in this direction. The force on 2 due to 1. The force on 2 due to 1, this is in this direction. F21 is opposite to the F21. These are the vector forms, just vector forms of the gravitational equation. The next one is the gravitational force on point masses due to the number of point masses. Means here if you observe, this is simply multiple masses. The gravitational force due to multiple masses. Whenever if you consider more number of masses, then how can you write the equation? This is a basic diagram. There are different masses M1, M2, M3 and M6 up to M6 given in this equation. On M1, the forces acting on M2 acting on force M1. There exists between forces between M3 M1, M4 M1, M5 M1 and M6 and M1. Whenever we consider the multiple masses, then we can write the gravitational force equation in this fashion. How can you consider? The M1 is a given given mass. We consider mass on M1 due to other masses. Here we just represent direction. F12 nothing but this acting along R12. This is only unit vector. We remember whenever we take cap R cap 1 2 nothing but this is unit vector, only represent direction. The forces acting on 1 and 2 between 1 and 2, that is along the separation or the displacement vector between the two masses. The basic equation is same. This represents only direction. In the same way, this is due to 2 and as well as due to 3 on 1 along R13. In the same fashion, you can write 14 G M1 M4 by R14 whole square into the force is acting along 14 along the 14. In the same way, you can write 1516. If you take addition of all these forces, you can obtain the resultant equation on that one. That is also called superimposition of forces. Here F12, F13, F14, 15, 16. That's nothing but the force acting on 1 due to 2, 3, 4, 5, 6 like that. Then the equation is we can write like this. If they give multiple masses, how can you find the net gravitational force? From this equation, you can find net gravitational force acting on mass M1. In the same way, you can write in any direction. Suppose if you they give directions also sometimes in our problems. Maybe force acting on I cap, along I cap, or along J cap, along K cap. Then you can write the equation. Suppose this is a force vector. Suppose 3 I cap plus 3 J cap plus some 4 K cap. This is a force vector. Nothing but 2 units force acting along I direction, 3 units force acting along J direction, 4 units force acting along K direction. Means algebraic sum of all forces. Algebraic sum of all forces. There is an MCQ based upon this one. 3 equal masses M fixed at vertices of equilateral triangle ABC. What is the force acting on mass 2m placed at the centroid of triangle? They gave some 4 options. Which one is correct option? In this fashion, Fr equals to 0. Why? Because this is the triangle. This is the centroid of the triangle. There are the mass 2m is placed at the centroid. The forces acting, there is one force acting, means 3 masses placed on vertices of triangle. then the net force acting on 2m due to these three masses is 0. F resultant is 0. F resultant is 0. The same problem you can solve in electricity or electrostatics. In that electrostatics, three charges are placed. Three charges are placed. Some charge, whatever amount it might be. Suppose in your NCERT textbook there is a question that is the charge Q is placed at the center. Three charges placed at the vertices of the triangle. What is the net electrostatic force in this case? In this case, the net electrostatic force at the centroid is also 0. These two are in similar fashion. How can we solve this problem? In any closed path, we remember in any symmetrical closed path. Why? Because this is an equilateral triangle. If you take a square, if you place a mass or a charge at the center, if the net force on this mass due to the masses at vertices of this square, the net force is 0. If it is symmetrical, means if it is a square. In the same way, if you place charges at here and there is a charge at center, that is we studied in electrostatics. Both are in similar fashion. The net force is 0. The net force is 0. If it is a square, regular square, or it is a equilateral triangle, or it is a regular hexagon, if you place a mass in at the center, the net force acting at the due to other masses is 0. The net force due to other masses is 0. If you observe the basic derivation for this one, the basic derivation is like this. There is a forces acting on this one. There is no need to derivation actually here. If you observe this one, this is A, this is B, this is C. The force due to A is here 2m is placed gm1 m2 by r square, the basic equation. Let here take the separation is 1 unit in each case. The first one, the force acting along OA is g m1 m2. Why? Because here m1 is 2m, m2 is m1 m2 by r square. We consider this is 1 unit, this is 1 unit, this is 1 unit. In such a case, 1 square is 1. That is force acting along OA, means the force acting on 2m due to this mass. If you same consider OB is not in particular direction, means not in along x or y or z. In such a case, we have to resolve components. Here, along B nothing but here g m1 m2. This is a vector. This is a vector. If you resolve into two components like this, simple. Here, this is negative direction, negative I direction. This is negative j direction. And how much angle it have? 30 degrees. It have 30 degrees with this horizontal. This is also 30 degrees. If it is 30 degrees along negative x direction minus I cos 30, along negative y direction minus j 30. If you resolve in the same way, C, OC, you can resolve in like this. If you add these all these things, that is the resultant force. The resultant force you obtain 0. That is 0. Okay, let's know what are the characteristics of gravitational law. We already discussed the characteristics of gravitational force. In the same way, here also we discuss about gravitational law. The first one is that is the basic gravitational law. F is equals to g m1 m2 by r square. The gravitational force is independent of intervening medium. We already discussed it. It does not depend upon medium. Does not depend upon medium. Some cases they are asked like that. If there is an object or there is another object placed between the two planets, how the gravity changes? Means there is no change in the gravity. Why? Because that does not depend upon medium. And the second characteristic of this one is the gravitational force is conservative force. The gravitational force is conservative. We discuss what is conservative. The net work done due to the conservative force is 0. Such type of forces are called conservative forces. Next one, the force exerted by the first particle on the second is exactly equal to the force acting on the second particle due to the first particle, but they are acting in opposite direction. Okay, that is also basic property. The last one is the gravitational forces between two particles acting along the line joining. Line joining, that's why I represent vector direction. R12 cap. Nothing but here the cap represent direction. There is acting along exact the surface. This is R. The force is acting along this direction only, not in this direction or not in this direction. The force is acting along the line joining between the two masses. That is the next important property. Based upon this concept, we can attempt this MCQ. What is the gravitational force? Does not depend upon the gravity. Exactly, the correct option is the intervening medium. Does not depend upon medium. It's depend upon product of masses and square of the distance between them, and is also depend upon, yes, these two are important. Is depend upon these two parameters. It does not depend upon medium. This is the correct option is option 1, option A here. The next one is acceleration due to gravity on the surface of Earth. On Earth, how can you calculate gravity at different locations on Earth's surface? This is also important concept in examination point of view. That basically the acceleration experienced by some mass m calculated from Newton's second law. The force is equals to, actually the force equation is F is equals to ma. Whereas if you consider gravity, instead of a, you can write g here, or you can write this equation as F is equals to g m1 m2 by r square. Suppose inside the Earth surface, how can you write? This is the surface. If you move at a distance r, if you assume a sphere at that distance, means if you a person standing on the sphere, he experiences gravity only due to the sphere only, not a outer surface. Due to the only whatever the surface is standing, that surface only is experienced gravity. Thus, in such a case, we consider this is r, this is smaller. The equation in such a case we can written as like this: F is equals to g mass of Earth, mass of object by r cube into r. If you consider the gravity on the surface of Earth, if you consider a person on the surface of Earth, this is the Earth surface. So we assume this is an Earth surface, then r is rewritten as a capital R. R is equals to capital R in this case. Then such a case, r will be cancelled, one r will be cancelled. The remaining equation is g m1 m2 by r square. The same fashion. Here is also, this equation is useful to find force inside the Earth surface. Inside the Earth surface. If you cancel the m on both sides, then the equation is g m1 m2. This equation can be written as mm will be cancelled. Then the equation can be written as like this. This is in the fashion. Only for the equation for gravity, g is equals to g me by r cube into r. This is the gravity inside the Earth surface. Okay. If mass is situated at r equals to r, the basic equation is at the surface. Just I told you, that is if r equals to re, if that is separation from the center, it is equals to radius of Earth. Then such a case you can write, instead of small r, you can write radius of Earth. One r will be cancelled. The remaining equation is r square here only. Here g is equals to gm by r square. That is the basic equation. This is the acceleration due to gravity on the surface of Earth. G m e by r square, or simply called gm by r square. This, by using that formula, Cavendish determined what is the value of g. And on the Earth surface, if you consider g is equals to gm by r square. This is the Earth surface having some radius. Earth radius here taken as capital R. If you consider g on the Earth surface, that is the equation. How Cavendish determined the value of g. G is equals to 6.67 to 10 power minus 11. The m equals to 6.6 into 10 power 24 kgs. The mass of Earth. That is the mass of Earth. You know what is r? R equals to the value of r is 6 into 10 power 6.4 into 10 power 6 meters, or 64 into 10 power 5 meters. If you substitute those constants, we can obtain what is g value 9.8 meter per second square. That is the gravity or gravitational acceleration on the surface of Earth. On the surface of Earth, g is equals to 9.8 meter per second square. This is the value of gravity on the surface of Earth. And also, we can obtain the gravity at different locations. Means some height, or if you go some depth, we can obtain gravity equations. The gravitational force of attraction always acting towards the center. That's why these forces are called central forces. These forces are called central forces. Why? Because it acts towards center of object. Here, center of it. The gravity at height. If you consider gravity at the same equation, the same fashion, everything is same, but at some height at h. This is Earth surface. At some height, if you move some height h from the surface of it, the gravity of mass were obtained as like this. G m by r square is the same fashion. Here the weight is equal to gravitational force. The weight is nothing but the force due to the gravity. The weight is nothing but the force due to gravity. Now the weight at this surface at the height h is equal to mgh at that surface. We can obtain that what is the gravitational force equation? The gravitational force equation is Gm by r square. Here Gm1 m2 by r square. R is nothing but r plus h, because this is the radius r and this is the h height. Then such a case r plus h is the total height, total distance from the center. We can write r plus h whole square. The basic equation we can obtain like this: G equals to Gm by r square. G is equals to Gm by r square. Here is also same fashion. G is equals to Gm by r square on the surface only. If you move h height from the surface, instead of r, we can write Gm by r plus h. That's it. This is the basic equation for gravity. Above h height from the surface of Earth, G is equals to Gm by r plus h whole square. This is the equation. And the next one is expression for G in terms of small g. On the surface in terms of small g. Here GH we obtain that Gm by r plus h whole square at some height. On the surface we can write G is equals to Gm by r square only. That's why from this equation we can write G capital M is equals to Gr square. If you rearrange this equation, r square move to the left, Gr square, that equals to Gm. Instead of Gm you can write Gr square. Then such a case, Gr square we can obtain like this: Gr square r plus h whole square. Then Gh, what is the Gh equation? If you take common G here, r square by r plus h whole square, r by r plus h whole square. This is the equation. Means here G in terms of small g, G at h height in terms of small g. This is important equation. And if you consider at d depth, G at d depth, nothing but here the radius of Earth is capital. We have just to move from the surface of Earth to distance d towards center. In such a case, the remaining distance is r minus t. The total distances are. If you move d depth, the remaining is r minus t. Means here we consider a sphere with radius r minus t. This is the radius is r minus d only. The radius is same in all directions. The radius is r minus t. We consider here the gravity value at a depth d, having radius r minus t. Okay. In such a case, we can obtain the equation in this fashion: G is equals to the basic equation is Gm by r square. What is the Earth is a sphere, the mass can be written as 4 pi r cube into rho, volume into density. Here mass equals to volume into density. The volume of the sphere is this one, capital B, into density. The mass is equals to density into volume. Thus we can write like this: G is equals to Gm by r square. If you substitute capital M value here, 4 pi r cube rho, we can obtain this equation: G is equals to r square. R square will be cancelled. Again, one r is left here. This way r is 10 here. The remaining equation is 4 pi G r rho. This equation is also important while you are calculating or simplifying problems. Small g is equals to 4 pi G r into rho. This is also important equation. This is one case. This is the gravity on the surface only. Okay, this is on the gravity on surface of Earth only. If you consider the gravity at a depth d, you can obtain equation like this. That is called here taken as g dash. G dash is supposed to, instead of r, you can write r minus d. Why? Because we are obtained at r minus d radius only. At r minus d radius only. Here, in the same fashion, you can obtain g is equals to g into m dash nothing but 4 pi r cube rho. R nothing but r minus d. Why? Because we are calculating at a depth d. The remaining terms are same. You can obtain this equation g dash. This is on the surface. This is at depth d. If you divide these two equations, you can obtain g is equals to this equation. We derive g dash at some depth d. In such a case, if you g dash by g means 2 by 1, what we get? R minus d by r. R minus d by the remaining terms are cancelled here. 4 pi g rho is cancelled. The remaining terms are r minus d by r. If you rearrange this equation, g dash, just move small g to the right side. Just move this g to right side. G dash is equals to g into 1 minus d by r. You have to keep in mind this equation is important. G dash is equals to g into 1 minus d by r at depth d. Okay, this is the gravitational acceleration at a depth d. Means here if you observe this equation, g minus something nothing but it is decreases as you move towards the center of Earth. It is decreases. Or in the same way, if you move away from the at the surface, g is also decreases. Towards center also g decreases. At the center of Earth, g is equals to how much? 0. That is also weightlessness condition. G equals to 0 at center of Earth. At center of Earth. Based upon this one, you can attempt this MCQ. What is MCQ here? Acceleration due to gravity at a depth d from the surface of Earth is. Just to obtain the equation. What is the correct option here? What is the correct option? Option 1. Option 1 is correct. Next, as we go below the surface of Earth, the value of acceleration due to gravity increases or decreases? Obviously, decreases. Yes. The next one is effect of rotation of Earth on acceleration due to gravity. The effect of rotation is also important. If you consider a diagram in this fashion, the variation of g due to the rotation of Earth is is spinning around its own axis. Due to that rotation, the gravity varies. How it is varies? Means here the radial vector make an angle some phi with equator. We consider gravity at this point P. We have to calculate the gravity at point P. Here the phi is angle made by the radius vector with horizontal. Phi is angle made by this radial vector with horizontal line. What are the forces acting here? Means if an object is situated at point P, there is a weight acting towards the center of Earth. If an object is here, if a person standing here, the force is acting mg acting towards center. That is mg towards center. There is another force which acting as it is spinning, the centripetal force or centrifugal force. Here the centrifugal force acting away from the center. That is, what is the value of centrifugal force here? M r omega square or m omega square r is the centrifugal force. Generally we taken as mv square by r, or if you write v is equals to r omega, we can obtain m omega square acting away from the center. These are the two forces acting on a person. As mg acting downward, here mg acting downward towards Earth center, m omega square acting away from the center. Means these are acting in opposite directions. So somewhat mg is affected due to this m omega square r, due to the spinning of motion or the rotational motion of Earth. Due to the rotational motion of here, if you obtain this equation, you can obtain like this. At some height latitude, we consider that r distance from the center of axis of rotation. This is the axis of rotation. There is r distance. In such a case, mr omega square acting away from the center. away from the center of this latitude. If this is phi, this is also phi, because these are two adjacent angles. In such a case, all these are not important. What is the net force equation? That is important here. If you observe this diagram, mg dash is equals to mg minus mr omega square cos phi. Why? Because we consider here mr omega square acting in this direction, away from the center, away from the center. But we have to consider the component at this latitude only. Here, if you observe this one, mg acting towards the center as well as mr omega square, the component along, this is mr omega square, the component along this radius is mr omega square cos phi. Mr omega square cos phi means mg is acting downward, mr omega square cos phi acting upward or away from the center. This is center. Towards center, away from the center. Then in such a case, what is the net force acting at that particular point P? That is mg towards mr omega square cos phi component acting away. Okay. Then in such a case, we can consider, if you cancel m in all equations, g dash is equals to g r omega square cos phi. Or you can write like this in this fashion also. Here, if you obtain this one, omega square cos phi is same. Instead of r, you can write from this triangle. From this triangle, if you take cos theta is equals to adjacent side by hypotenuse. Adjacent side by hypotenuse. That's why here, instead of r, instead of smaller, you can write r cos phi. Why? Because cos phi is equals to here small r by capital R. Here cos phi is equals to small r by capital R. That's why you can obtain equation. Instead of small r, we can write r cos phi. The remaining terms are same. If you simplify this equation, the final equation is important here. G dash is equals to g minus r omega square cos phi. This is important equation. You should keep in mind. Just note this equation. G dash is equals to g minus r omega square cos phi. This is the gravity at some latitude or the gravitational acceleration due to the rotation of Earth. Here we consider phi also. Based upon this equation, we can obtain the gravity at different locations. If you want to represent with respect to this axis or equatorial line, if you move 90 degrees, you reach equatorial line or at poles, North Pole and South Pole of it. If you want to obtain at poles, the gravity with latitude due to the rotation of Earth at poles. This is Earth surface, Earth is spinning in this direction. The gravitational acceleration at point P, as theta is equals to 90, just write phi equals to 90 degrees in that equation. Just write phi is equals to 90 degrees. If cos 90 is 0, cos 90 is 0, that's why at poles, what is the gravitational acceleration? Just Gp is equals to 0. Why? Because this term vanish. Why? Because cos 90 is 0. This make 90 degrees with this equator or horizontal line. Such a case, this term vanish. G at P equals to Z. P is equals to G is equals to Gm by R square. This is the equation at poles. G is equals to, or G at poles is equals to Gm by R square. In the same way, you can obtain equation at rotation motion of Earth, variation of Z at equator. Just to consider same equation, G dash is equals to G minus R omega square cos phi. At equator, what is the angle here? At equator, it makes with the horizontal, it makes the theta degrees. Theta equals to 0 degrees. Such a case, write cos 0. Cos 0 is 1. So here, G at equator is equals to G minus R omega square. This is the equation. G minus R omega square at equator. Due to the rotation of Earth. All these things are what we discussed here. Here, if you observe at poles, what we obtained equation? G at poles is independent of rotation. Why? Because G at poles is equals to, we get equation G or Gm by R square. This is equation at poles. That's why it is independent of rotation. If you consider rotation, there is a angle term. Angle term nothing but here phi term is there. Then that is dependent. Otherwise, it is independent. At poles, we are obtaining equation G P is equals to G. That is Gm by R square. That's why I said independent of rotation of Earth at poles. And in another case, due to rotation of Earth, G is maximum at poles. This is the maximum value, and minimum at equator. Why? Because we said minimum? Because at equator we obtain equation G at equator is equals to, what is the equation here? R omega square, means G minus something, means G is decreases. G is minimum at equator, so G is minimum at equator. Okay, G is maximum at poles. Based upon this concept, just try to get this MCQ. What is the answer? As one moves from north pole of Earth to south pole, the value of G along the path. How G changes? North pole to south pole. North pole to south pole means in this fashion. This is where this is north pole, south pole. As a person moving towards at the center of Earth, G, I said, decreases. G decreases. Okay, means here, if a person standing here, to consider gravity due to this pair only. If a person standing here, to consider gravity only this pair only. Means at the center G is equals to 0, I said. Again, he is moving like this, means the gravity again. The sphere volume is increases or mass is increases. This way towards center means initially it is decreasing up to center of Earth. Later again it is increasing. Means it decreases and first decreases, then increases to its initial value. Again, whenever a person reaches south pole, south, then G is equals to again G. That does not change. Here also G. At center 0. Means first decreases, later again increases. When a person moves from north to south. This is the correct option. This is also important question. Why? Because a similar question may appear in electrostatics also. The center of Earth having radius or variation of G is just what we discussed here. This is the radius R. Here, if you observe from the, if a person moving from the center to the surface of Earth, the G value gradually increases with the distance R. With the distance R, G value increases. Later, and as moving away from the Earth surface, G decreases. And the surface and square. This way, the same graph here obtained here increases linearly up to what? Up to R is equals to the radius of that. It is increases. Later on decreases. It follows in a square law. That's why the graph obtained like this. That's why the correct option is here. Option B. Same question in electrostatics. That is due to the solid sphere. What is the force? Due to the solid sphere. That's in such a case also we obtain the same curve. Up to center, the uniformly distributed charges. If charges are distributed uniformly, such a case just we obtain up to R. The forces are increases, after that is decreases. Away from the surface, it is decreases. The next one is the speed of rotation of Earth decreases. The value of G. This is also a conceptual question. Which one is correct answer here? Which one is correct? I said that at poles it does not depend upon rotation of Earth. Okay, at poles it does not depend upon rotation of Earth. It depends upon rotation only at the equator. That's why, and also it is decreases. It is the speed of rotation of Earth decreases here. It decreases. It is decreases. Why? Because G at equator is equals to G minus R omega square. This is the equation of time. Here G at equator equals G minus something. Minus something nothing but here some quantities decreases. That's why here G decreases at equator. It does not depend upon poles. That's why these are not cases at poles. Okay. The gravitational intensity. What is the intensity here? Intensity nothing but here the force acting per unit mass. The force acting per unit mass is intensity. We can reduce like this. This is a Earth surface. Suppose some mass m0 is kept on the gravitational field. Means there is a field. This is the whatever the dotted line represent the field of this at the point m0 is placed in that field. In such a case, that is separated at a distance small r from the center, the mass of Earth is capital M. Then what is the force on that particular M? The force equation is G m1 m2 by r square. That's why here we write like this, according to Newton gravitational law. The intensity represent here E is equals to the force per unit mass. The force per unit mass nothing but F by m0. The force acting on that mass. That's why F by m0 is how much from this equation? If you rearrange, if you move m0 to the left, the remaining equation on right is Gm by r square only. Gm by r square. This is the equation for intensity. In the same way, electricity. Gm by r square is the equation for the gravitational intensity. And what is the potential? Gravitational potential. The gravitational potential nothing but here, everywhere the potential is nothing but work done. Everywhere the potential is work done. Here, in order to bring a mass from infinity to infinite, nothing but the point outside the field. This is what of the shadow, that is only field. Here the mass m is outside the field. If you want to bring this mass to into the field at a point, you have to do some work. That work nothing but here the gravitational potential. The work done to bring a mass into the field. That is the potential, gravitational potential. This way here we are obtaining like this, the same way from infinite, here I am not, to the distance some r distance. That is the gravitational field, the gravitational potential. That is the gravitational potential. Everywhere the gravitational potential is nothing but the work done to bring a unit mass from infinity to a point in the gravitational field. And what is the gravitational potential energy? The potential energy equation is simply we define like this: mass into gravitational potential mv. Here also in electrostatics you observe that in electrostatics if you compare the similar equation like this, W is equals to the work done is equals to Q into V. Q into V in electrostatics. In electrostatics, the work done nothing but here also this is also potential. Our potential energy is equals to QV. The work done is potential. Instead of Q, here we write mass. The potential is V. Here also the potential represented with V. This is the gravitational potential mass. This is the product gives us gravitational potential energy. The gravitational potential energy. Here we can write instead of what is the potential Gm by, just explain Gm by R square. Gm by R only. V is equals to minus Gm by R is the gravitational potential. V is Gm by R is gravitational potential. What is the negative sign represent here? The negative sign represent attraction. Everywhere, if there is a negative sign for a field or forces or potentials, the negative sign represent attraction. Means the nature of forces here is attraction. Means we no need to work in that particular field. The work done by the system. If the work done by the system is negative. The potential energy equation, if you arrange that equation Gmm by R only, But whereas in force equation we obtain R square, in potential equation or potential energy equation G mm by R only. G mm by, this is the gravitational potential Gm by R. Based upon this one, we have a problem. Infinite number of bodies, each mass 2 kg, are situated on x-axis at distance 1 meter, 2 meter, 4 meter, respectively from origin. The resulting gravitational force due to this system at origin is, means there are different masses at origin. There is infinite number of masses, 2 kgs each 2 kgs at 2 meters, at 2 meters, at 4 meters, at 8 meters, like this in this fashion. We have to find the gravitational force is nothing but G is equals to Gm by R only. We have to write equation for each term. Nothing but here if you obtain, and the equation is G is constant, M is 2. What is R? R changes here. R means at 2 meters, means 1 by 2 plus 1 by initial at 1 meter. 1 meter, 1 by 2, 1 by 4 meter, 1 by 6, 1 by 8 meter in the same fashion. If you observe this one, minus is in the formula, why? Because this is attraction, minus 2g into, this is in geometric progression. 1 plus 1 by 2 plus 1 by 4 plus 1 by 8. Geometric progression. The sum of terms up to infinity terms. The sum of infinity terms is, the formula is A by 1 minus R. What is A? A is the first term, R is the common ratio. What is the ratio here? Ratio nothing but the second term by first term equals to third term by second term, or fourth term by third term. The ratio is same here. What is the ratio? 1 by 2 by 1 is 1 only. That's why you can write R is equals to 1. R is equals to 1 by 2. R is equals to 1 by 2. That is common ratio. 1 by 1 minus 1 by 2. A is first term. What is the first term? 1 by 1 minus 1 by 2. The value here is 1 minus 1 by 2 is 1 by 2. Take reciprocal is 2. 2 to the 4. That's why the correct option is 4G. We obtain the solution like this. This is the solution of that one. The same fashion, due to the potential due to first one, potential due to second, third one, fourth one. We write equations, then take common 2G. In the first term, only 1 is there. Why? Because take common 2G. The second term, 1 by 2, 1 by 4, 1 by 8, like that. This is in geometric progression. The sum of terms formula is A by 1 minus R. A is here the first term. R is the common ratio. Everything ratio, nothing, ratio is same. 1 by 2 by 1 is 1 by 2. 1 by 4 by 1 by 2 is 1 by 2. The ratio is same, that is 1 by 2. If you simplify this one, the equation is minus 4G. This is the correct option is minus 4G. The next one is gravitational potential energy. You already derived the equation. G mm by R. The gravitational potential energy at some height h. Means at a height h, nothing but just replace R by R plus h. R by R plus h. If you want to find the gravitational potential at h height, just replace R by R plus h. This is on the surface. This is on the surface. If you write the equation R plus h, means at some height h, R by R plus h. This is on the surface G mm by R, at height h, R plus h. The gravitational potential energy represented here U. The derivation is like this. The gravitational potential energy, nothing but take force Gmm by R square. Gmm by R square. If it is separated at x distance, Gmm by x square. That is force. If you want to find the potential nothing but work done. What is work done? Work done is nothing but here. W is equals to integral from of work done is F dot ds. F dot ds. If W is equals to here Fs, if you want to find the total value, W is equals to 4, work done is equals to force into displacement. you want the total value, just integrate the equation. What is the equation here? Integral from infinity to r. Means you are moving an object outside the field, infinite distance to some r distance. This is r distance. From this point, infinite distance. From this point, r distance. That's why here the integration limits are infinity to r, g mm by r square, or here x square. Here obtain this. If you integrate that equation, g mm by r minus g mm by r is the potential equation. At some height, if you want to write equation for gravitational potential energy, g mm by r plus h. This is simple. The next one is, if you want to move some h1 height to h2 height, if you want to move two objects, the same equation is used here. W1 is equal to g mm by r plus h1. In the same way, to h height 2 r plus h2. Then what is our net work done? Means here some height h2. This is the Earth surface. Initial object is at h1. If you want to move h2 height, this is h2. This is h2. If you want to h1 height to some h2 height, this is at h1 height. This is h1. This is h2. In such a case, what is work done? If they are asking a work done, they depend upon this formula. Means here the work done to bring from h1 height is g mm by r plus h1. From height h2, g mm by r plus h2. What is the net work done? Net work done nothing but here w2 minus w1. The equation is g mm into 1 by r plus h1 plus minus 1 by r plus h2. This is the net work done to move h1 to h2 height. Based upon that one, there is a problem here. A gravitational potential between the surface of planet and 10 meters above is 5 kg. Basically, they gave gravitational potential value, potential difference value. The gravitational field is supposed to be uniform. The work done in moving a 2 kg mass from surface of the planet to height h meters. Here simply you can take here 5 joule per kg. Indirectly, the kg nothing but here mass is included, right? That what is the basic equation? mgh generally, that is the energy equation. The mgh value is 5 joules. mgh value is 5 joules. From this equation, we can obtain what is the g value. This is at h height. What is g value here? They gave a gravitational potential difference on the surface of planet. But what is the planet? We don't know. That's why first we have to calculate g value on that planet. G is equals to 5 by h. 5 by what is the h value here? 10 meters. What is the g value? 1 by 2. 1 by 2 is the g value on that planet. On that planet, we have to find work done. The work done is nothing but the potential energy, mgh. Here m is 2. G is we calculated as 1 by 2. Up to how much height you have to move? 8 meters. 2 will be cancelled. The answer is 8 joules. The answer is 8 joules. Means here two-step process. First we have to calculate g. Later on we have to use, depend upon that g, we can find the work done. That is the gravitational potential energy. 8 joules. The correct option is 4. The next one is, yes, this is also basic equation. A body weighs 200 newtons on the surface of it. How much will it weigh halfway down to center of it? If you move halfway down, nothing but that. If it is the radius r, just you move down, means at r by 2 you are standing. At r by 2 you are standing. In such a case, what is your weight? The basic equation, from the basic equation you can obtain the gravity at depth d. You are moving towards the center. That's why we consider the equation at a depth d. What is the equation for? If you want to, here we have to find weight. That's it. We have to multiply with m both sides. Because why? Because mg is weight. Mg is w is equals to weight equation. W is equals to mg. That's why here mg dash means the gravity at that location is equals to mg into 1 minus d by r. Here everything they give. mg weight on the surface is 200 they give. 1 minus, here d is equals to how much distance you move? R by 2 distance. R by 2 is written. That's why RR will be cancelled. 1 minus 1 by 2 is 1 by 2. 200 by 2 is 100 meters. The correct option is option. Means exactly half of the, at half distance, our weight is half of the weight at the surface. At surface it is 200 newtons. At half we have 100 newtons. Okay, these are the basic concepts in gravitation. Gravitation. In next class we will discuss remaining concepts of gravitation. Okay, thank you all of you. Meet again our next class.